In this video, we're going to look at the relationship between correlation and risk reduction in the context of a portfolio of stocks. This is a topic that you should have covered in an introductory finance class, but I want everyone to be on a level playing field as we go forwards, and it never hurts to go over this topic again. Returns on a portfolio are going to be equal to the weighted average of the returns on the securities in the portfolio. If we look at this formula for the portfolio returns, we can see it's the sum of the weights in stock I times by the returns on stock I for all stocks I equals 1 to M, where M is the total number of stocks in the portfolio. WI, the weight that we put on stock I, represents the proportion of the portfolio that is taken up by stock I. And we know that in a portfolio, the sum of all the weights must add up to 1. So the portfolio return is easy to calculate using a weighted average. The risk of the portfolio, though, is not a straightforward weighted average of the variances of the securities in the portfolio. We have to take into account correlation. Correlation tells us about the strength and the direction of a linear relation between two variables. And correlation can range between -1 and 1. If the correlation is greater than 0, returns on two stocks tend to move in the same direction at the same time. If the correlation is equal to 0, then the returns on two stocks are independent. If stock A goes up, we have no idea what's likely to happen to stock B. Finally, if the correlation is less than 0, then returns on two stocks tend to move in opposite directions. So when stock A goes up, stock B tends to go down. At the extremes, we have perfect positive correlation. This would mean the correlation is equal to 1. And we have perfect negative correlation, which would mean the correlation is equal to -1. Here are examples of the two extremes. In the left-hand diagram, we have perfect positive correlation, and in the right-hand diagram, we've got perfect negative correlation. And you can see how stocks M and N move together in this diagram, while they move in opposite directions when they are perfectly negatively correlated. Now, how do we calculate portfolio risk and return? We know how to calculate the expected returns on a portfolio. We've just seen that formula. But we haven't looked at the formula for portfolio risk yet, or variance. For the two-stock case, the formula is written out below. The portfolio variance is going to be the weights in asset A squared times by the variance of asset A, plus the weights in asset B squared times by the variance of asset B, plus, and this is the correlation term, 2 times by the weights in asset A times by the standard deviation of asset A, times by the weights of asset B, times by the standard deviation of asset B, times by the correlation between A and B. Rho is equal to the correlation. This is the formula to calculate portfolio risk in the case of two stocks. And we have an example above. The expected returns on stock A are 9%, and the standard deviation on stock A's returns 12%. For stock B, we have expected returns of 18% and a standard deviation of 25%. The correlation between stock A and stock B is -0.5. To calculate the portfolio risk and return, if we invest 25% in stock A and 75% in stock B, we just have to plug the numbers into the two formulas above. First, let's consider expected returns on the portfolio. We invest 25% in stock A times by the expected return, which is 9%, plus we invest 75% in stock B times by the expected return on stock B, which is 18%. If we do that calculation, we get the expected returns on the portfolio are equal to 15.75%. Now let's think about the risk of this portfolio. Again, we just plug in the numbers. So we've got WA squared, so we've got 0.25 squared times by the variance, and we know that the variance is going to be equal to the standard deviation squared plus the weights in asset B squared times by the variance of asset B, which is 0.25 squared, plus the correlation term, which is going to be 2 times by the weight in asset A times by the standard deviation of asset A times by the weight in asset B times by the standard deviation of asset B times by the correlation, minus 0.5. That gives us a variance of 0.03% squared. Percent squared is just a unit of measurement, like miles per hour. So when you see percent squared, it's just referring to variance, that's all. Suppose we want to look at all the possible combinations of asset A and asset B. In this diagram, that's what we've plotted. I've plotted on the horizontal axis the standard deviation of the portfolio, and on the vertical axis I've plotted the expected returns. If we invest everything in A, then we earn returns equal to 9%, and we have a standard deviation of 12%. As we increase the amount we invest in asset B, so we see our expected returns increasing, while our portfolio risk, or standard deviation, actually decreases. But at some point, as we start adding more and more of asset B, so the risk of the portfolio starts to increase again, until we invest everything in asset B, and here we have expected returns equal to 18% and portfolio risk equal to 25%. This is with a correlation between assets A and B of minus 0.5. Here's what happens if we change the correlation between asset A and asset B. First, let's consider the most extreme negative case, where the two assets are perfectly negatively correlated. When the correlation is equal to minus 1, we can see huge benefits to diversification. As we take on less extreme values of the correlation, such as minus 0.5, so we see the benefits of diversification decrease. If we want to earn expected returns of 12% now, we have to take on more risk. Similarly, if the correlation is 0, we have to take on even more risk to earn the same expected returns. Finally, if the correlation is 1, so these two stocks are perfectly positively correlated, we have to take on the most risk to earn expected returns just under 12%. This diagram clearly highlights the relationship between correlation and diversification. As we move from a negative, perfectly negatively correlated stock, so we see the benefits of diversification decreasing. It's important to understand why this occurs. Let's think about our formula for portfolio variance. We know that the portfolio variance is equal to the weights invested in asset A squared times by the variance of asset A plus the weights in asset B squared times by the variance of asset B plus 2 times by WA sigma A WB sigma B all times by rho AB. Now suppose rho AB equals 1. In other words, the two stocks A and B are perfectly positively correlated. We can rewrite our formula. portfolio variance is equal to WA squared sigma A squared plus WB squared sigma B squared plus 2WA sigma A WB sigma B. The row AB drops out because it's equal to 1. Now this expression may look similar to an expression you saw in high school. A formula here, we have A squared plus B squared plus 2AB is equal to A plus B all squared. We can apply this formula to what we see above. We would have A would be equal to WA sigma A and B equal to WB sigma B. So if the correlation between A and B is equal to 1, we find that the portfolio variance is equal to WA sigma A plus WB sigma B all squared, which means the portfolio standard deviation, which is the square root, is going to be equal to WA sigma A plus WB sigma B. In other words, if the correlation is 1 between the stocks in the portfolio, then the portfolio standard deviation, or risk, is just going to be a weighted average of the risks of each individual stock. If, however, the correlation is less than 1, then we know that the portfolio standard deviation must be less than the weighted average of the firm level standard deviations. So as long as the correlation is less than 1, there will always be some benefits to diversification and investing in multiple stocks. In reality, it's very hard to find assets or stocks that are perfectly correlated. In fact, it's probably close to impossible. That means that portfolio standard deviation is not just a weighted average of the standard deviations for each firm. Holding a portfolio of stocks helps to smooth out firm-specific risk events in a portfolio. Why? Because the positive performance of some investments will neutralize the negative performance of others. And the benefits of diversification will always hold as long as the stocks in the portfolio are not perfectly positively correlated. Now let's move to Excel to see how we calculate portfolio risk and returns in reality. Here we have price data and return data for 5 stocks: Intel, AEP, Amazon, Merck and ExxonMobil. And we need to calculate portfolio returns and risk. Before we do that though, let's see if we can calculate the correlations between Intel and AEP and Intel and Amazon, etc. First thing we need to do is copy and paste the labels so that we know what we're looking at. This is going to be correlation. And if we want to paste these cells vertically, we have to paste special and paste the transpose so that these cells are aligned vertically. To calculate correlation, we're going to use the formula CORREL, C-O-R-R-E-L, and then we're going to select the first stock that we want to look at, which is Intel, and then we need to select the second stock we're going to look at. In this case, if you look at our matrix, we're looking at the correlation between Intel and Intel. We know what that's going to be. The correlation should be equal to 1. So it's a good way to check that we've got the right formula and the right data. And that's what we see. The correlation is equal to 1. We also want to calculate the correlation between Intel and AEP, Amazon, Merck and ExxonMobil. We can do this by copying the formula across. But when we copy the formula across, all the variables up here will change. And we want to keep one of the arrays to be Intel's returns. We don't want that to change as we copy the formula across. To stop Excel from shifting these cells across and changing them, we just put a $sign in front of them. That means that this column will always remain the same. We can check that by now copying the formula across, and we can see that each time we're looking at the correlation between Intel's returns, which is the H column, and in this case AEP's returns. We can calculate the correlations for all these stocks using the same formula. Do these correlations make sense based on our intuition? We would expect Intel and Amazon to be positively correlated because they are tech firms. And that's what we see. Intel and Amazon are positively correlated. We would not expect Intel and AEP to be very highly correlated because AEP is an electricity company while Intel is a tech firm. And that's what we see. Similarly, we would expect there to be very few relationships between ExxonMobil, an oil company, and Amazon, a tech firm. We do see, however, a positive correlation between AEP and ExxonMobil and Merck and ExxonMobil. AEP will use oil in its electricity production, and a key input for Merck is often oil-based products. So it might make sense that we see a positive correlation between AEP and ExxonMobil and Merck and ExxonMobil. Whenever you do calculations in Excel, it is important to check that the results are consistent with your intuition. If they're not, you may have made a mistake. It's very easy to make a mistake in Excel. So if you find that your results are not consistent with your intuition, you should check carefully your calculations. Now suppose we want to calculate portfolio returns, and we're going to have an equally weighted portfolio of each of the 5 stocks across all the months in this data sample. There's a quick way to do this, but it relies on a couple of tricks. The first thing we're going to have to do is name some cells. You may or may not be familiar with naming cells or ranges of cells. And the first thing you should do is go to the Formulas tab, go to the Name Manager, and check that it is empty. So there are no named cells in this spreadsheet at the moment. What we're going to do next is select the returns for Intel, AEP, Amazon, Merck, and ExxonMobil. Select that range of cells. Now we're going to name that range of cells returns. Just press enter. Now you can refer to this range of cells by the name returns for any calculations that you do. The second step to calculate portfolio returns is to set up a weights matrix. And we know that the weights are going to be equal to 20% for each firm, and this stays the same across all months. So we copy this down. There we have our weights matrix. And what we're going to do is name this cell, this range of cells. We'll name it weights. Again, you can press enter. Now, whenever we refer to weights, we're referring to this range of cells. The final step to calculate returns on the portfolio is we have to multiply the returns by the weights for each stock and then add them up. We're going to split this into 2 steps. First thing we're going to do is weights multiplied by returns. Again, there is a quick way to do this. Select the range of cells where you're going to put the weights times by returns. Go to the formula bar and type equals weights, and you can see Excel recognizes that we've named a range weights, times by the range called returns. Again, Excel recognizes it. Do not press enter. what we need to do now is press Control, Shift and Enter. Excel will recognize that it needs to perform a matrix operation and fill out all the cells at the same time. So Control, Shift, Enter. We've now calculated weights times by returns for these 5 stocks. The final step to calculate portfolio returns just involves adding up the weighted returns for the 5 stocks. So portfolio returns are going to be equal to the sum of Intel's returns times by their weights, plus AEP times by the weights, plus Amazon times by the weights, plus Merck times by the weights, plus ExxonMobil times by the weights. And if we double click the bottom right hand corner, this formula will fill out down the page for all the returns. We can now calculate the average return on the portfolio, the variance of the portfolio, and the standard deviation of the portfolio. So average return is going to be equal to average, and then select the portfolio returns. So the average return is about 1.3% per month on this portfolio. The variance is equal to VAR and then the range, equal to about 0.3% squared. And the standard deviation is going to be equal to 5.566% per month. We've now calculated portfolio returns, and it was relatively straightforward. There's an awful lot of calculations involved, but we can speed things up in Excel by using clever tricks such as naming ranges. Now let's go back to PowerPoint. The average portfolio return was 1.3% per month. This was the weighted average of the individual stock returns. The portfolio standard deviation, though, is only 5.6% per month, while the average standard deviation of all 5 stocks was actually 8.9% per month. Why is the portfolio standard deviation lower than 8.9%? The reason is correlation. The returns of the 5 stocks are not perfectly positively correlated. So when we invest in this portfolio of stocks, we see that our risks are reduced relative to the scenario in which all the stocks are perfectly positively correlated. We can see this risk reduction on a graph. The bold black line represents the portfolio returns, while the other lines represent the returns on each individual stock. You can see the returns on each individual stock really do bounce around a lot. We have returns as large as plus 50% and as low as minus 30%. But the portfolio returns, we never see negative returns in excess of minus 12%, and we never see positive returns greater than 20%. This is because the good events, the good firm-specific events cancel out with the bad firm-specific events, so we get smoother returns. This is risk reduction. That's all I want to talk about for today's class. If you're not comfortable with the idea of correlation and risk reduction, please spend some time working through these slides, because we're going to be building on this over the next week or two. See you in class.